Hi, this video is to explain the solution to the review question number 5 from the Chapter 1 review exercises. This is the shopping question. We have a customer visiting the suit department of a certain store who'll purchase a suit with probability 0.22, a shirt with probability 0.30, and a tie with probability 0.28. A customer will purchase both a suit and a shirt with probability 0.11, both a suit and a tie with probability 0.14, and both a shirt and a tie with probability 0.10. We also know that the customer will purchase all 3 items with probability 0.06, and we want to try to figure out some of these probabilities. So first of all, I think when you've got a complicated system like this, the most straightforward way to answer this question is by drawing a Venn diagram. And I know that there has been some confusion about drawing Venn diagrams, so I want to work through how to do this with a Venn diagram and show you how straightforward it really can be. So we've got sort of 3 possibilities, well really 4. We have buying a shirt, buying a suit, buying a tie. We've got intersections of those things, and then we've got, maybe somebody might not buy anything, right? That makes up our entire outcome space. So when you're making your Venn diagram, you start filling in probabilities. What you want to do is you want to start with the biggest area of overlap first, right? So the customer will purchase all 3 items with probability 0.06. So here's the customer is purchasing all 3, so we know the probability in this area is 0.06. We start with that. Then we start with the next set of intersections. Right? So say, okay, we'll purchase both a suit and a shirt with probability 0.11. So a suit and a shirt, that's this area. The total in this area has to be 0.11, but I already have 0.16 in this 3-way intersection. So if I take 0.11 minus 0.06, gives me 0.05, and that has to be the probability of being in this area where you purchased a shirt and a suit, but not a tie. So the total probability of that intersection adds up. Okay. Next I move on. Okay, both a suit and a tie with probability 0.14. So suit and tie is here. 0.14 minus 0.06 gives me 0.08. So 0.08 here. So together these 2 add up to the 0.14. So I've got those pieces. And then the next intersection. So let's see. Both a shirt and a tie with probability 0.10. So I know the total I need there is 0.10. I already have 0.06 in the 3-way intersection. So that leaves me with 0.04 as the probability of purchasing a shirt and a tie but not a suit. So I've got sort of probability in each of these regions. And now I just keep working my way out. Say, okay, I know they'll buy a suit with probability 0.12. So I need to have a total probability of 0.22. 0.22. So 0.22, but I already have some of that probability gobbled up here. I need to subtract off my 0.05 minus my 0.06 minus my 0.08. Gives me 0.03 is the probability that a person buys a suit and nothing else at the store. And I move on. Buying a shirt with probability 0.3. So here the total probability in the shirt region has to add up to 0.3. So I've got 0.3. I'm going to take off the probability that's already been used up. minus 0.05, minus 0.06, minus 0.04, 0.3, minus 0.05, minus 0.06, minus 0.04, gives me 0.15 left over here. And then down here, say, okay, tie is purchased with probability 0.28. So I've got 0.28. But I've already used up 0.04, 0.06, 0.08. So 0.28 minus 0.04 minus 0.06 minus 0.08 gives me 0.1. So the chance of somebody buying a tie but not buying anything else is 0.1. Now I can figure out sort of what's the probability that's left over out here. Remember, the total probability has to be 1. So if I add up all of these probabilities, I've got 0.15 plus 0.05 plus 0.06 plus 0.04. That's all this part. 1, 2, 3, 4. Got those. Okay. Now I've got 0.03 plus 0.08 plus 0.1. The total probability I have that somebody buys at least one of these 3 items is 0.51. So what's left over is 1 minus 0.51. Gives us 0.49 out here. So now, when I come to answer my questions, things become very straightforward. There we go. What's the probability that a person buys none of these items? I can see very easily from my Venn diagram that the probability that somebody buys none of those items is 0.49. Right? Exactly one of these items. I can see these people in here, all of them are in the intersections, are buying 2 or 3 items. Here's the one, just a shirt, just a suit, just a tie. 0.15 plus 0.03, just a suit, plus 0.1, just a tie. Gives us what? 0.25, 0.28. Scooch that over. A shirt or a tie. So keep in mind that's a shirt or a tie or both. So here I've got a shirt or a tie or both. I could add up these values here. The 0.15 plus 0.05 plus 0.06 plus 0.04 plus 0.08 plus 0.1. Everything in the intersection here that doesn't not include a shirt or a tie. I could add those all up. Gives me 0.48. The other way I could do it is I could take the 0.51 and subtract off the 0.03. I know that the chance of buying at least something is 0.51. The chance that it doesn't include a shirt or a tie is 0.03. So 0.51 minus 0.03 would also give me 0.48. So that's sort of another way I could have done that. And then if the customer, if the customer buys a tie, so keep in mind that this is the probability of a shirt given that they buy a tie. Right? If is a given kind of statement. So I'm looking for the probability of a shirt and a tie divided by the probability of a tie. I can do that using these probabilities given up here or the Venn diagram, either one. If I do it with the Venn diagram, a shirt and a tie, I can see I've got 0.04 plus 0.06. Probability of a tie is 0.04 plus 0.06 plus 0.08 plus 0.1. This comes out to 0.1 over 6 times 14. Let me just add this up. .28, which is given up here. 0.1 divided by 0.28 gives me 0.3571. Just kind of pulling that over. But using this Venn diagram makes, sorting through all of these intersections pretty straightforward. You can do it all with formulas, but it's a lot easier to work with a Venn diagram in a situation that's this complicated. Okay, so that is question 5 from the review exercises.